Alright guys, I am back again for another video, and this one we are going to talk about salt. Yay! I know you guys are all really super excited, but let's talk about some salts. That's great. Specifically, we're going to be talking about the acidity or basicity of salts. So it's really important to understand what a salt is. A salt is a product of an acid and a base. So it's a product of an acid-base reaction. Okay, so that's what a salt is. I have an acid and a base react together, and a lot of times, all the time if they're Arrhenius acids and bases. If I have an Arrhenius acid and an Arrhenius base react together, it'll form water and a salt. Okay, and if I were to dry off that water, I would have just crystallized salt. Okay, so there are three types of salts in the world. There's neutral salts, there's acidic salts, and there's basic salts. So let's start with neutral salts. Okay, so a neutral salt, the cation, that's the positive ion, the cation is from a strong base. Now remember, a strong base is going to be a group 1 or 2 cation, as well as a couple of smatterings, but the big thing is a group 1 or 2 cation. I think ammonia is the other one, but a group 1 or 2 cation. So sodium, potassium, magnesium, those will form strong bases. So the cation from a strong base, so sodium, potassium, magnesium, cesium, I guess, and the anion of a strong base, or a strong acid, I'm sorry. So a neutral salt is going to be from a strong base and a strong acid. And those are, let's say, for example, we'll do my examples over here just for fun. NaCl, so that would be sodium hydroxide, NaOH, and HCl, hydrochloric acid. That would react to form sodium chloride. Let's say I had KNO3. Okay, so potassium hydroxide and nitric acid, both strong, etc. We can make the list go on and on and on and on and on. Okay, a neutral salt will simply dissociate. Spelled simply wrong. Simply dissociate in H2O. So an example of that, let's say KNO3, it's going to dissociate and turn into K plus and NO3 minus. Okay, so it would just simply dissociate. It's not going to really react with the water. It's not going to do anything. It just dissociates in the water. Okay, that is neutral. So let's get rid of our neutral. Let's do basic. Okay, so we have basic salts. Okay, so a basic salt, I still have my cation, that's the positive one, from a strong base. But in this case, my anion, oops, just messed that up a little bit, and I forgot to mention that that's the negative one, anion. It's going to be the anion of a weak acid. So neutral was strong and strong. Basic is strong and weak. Okay, and it's not too surprising that a basic salt's from a strong base and a weak acid. Okay, examples of that would be something like, I'm going to go a little off screen here, but that's okay. Something like NaF. There we go. Don't know why I didn't do that. Beginning. NaF. That'd be some sodium hydroxide, but that'd be from hydrofluoric acid, which is a weak acid. All right. Or let's say, I don't know, potassium cyanide. So that's from potassium hydroxide, and that's from cyanidic acid. I made that word up. I don't know if it's really called cyanidic acid. Hydrogen cyanide probably. Sounds a little bit more technical. Okay, so those would be basic. Now here's the issue. The anion since the anion is from a weak acid, the anion is also a conjugate base. So I have a cation, which is neutral. The sodium doesn't really do anything with the water at all, doesn't really do anything. But the anion is technically a conjugate base. So it's going to act slightly basic. All right, it's going to act slightly basic. So an example of that is, let's say we use our NaF. Okay, NaF is going to dissociate in water and turn into Na and F minus. Okay, that's no shocker. That's going to dissociate. But then the F minus will react with the H2O to form HF plus OH minus. Okay? So it's going to react to form HF and then OH minus. And that right there is a base. So my basic salts, my cation doesn't do anything, but my anion's the conjugate base of something. F is a proton acceptor, and it could accept the proton from the water, turning into HF and OH minus. It could accept the proton from anything, really. So that's why basic salts have to have a weak acid anion, because weak acid anions are conjugate bases, and conjugate bases are proton acceptors. Okay, you can probably see where this is going, right? Because we've got one last type, and I'm a little bit nervous that I'm going to run out of room. So I'm going to erase my neutral. Oh boy, green does not erase very well at all. That's a fun factoid. I'm going to get my wet paper towel here. Okay, so, wow, not even a little bit. Okay, so I'm going to erase the basic one then, because you don't want to stare at the back of my head while I scrub down the dry erase board. So, okay, so, wow, that's a note to self. Don't use green. Okay, so I'll do that later, I guess. Okay, so, boy, this is asking for it, but I'm going to try red. That's not going to work out well for me. Okay, that's still a little bit, there we go. That's not too bad. A little damp, but we'll make do. Okay, so acidic salts. Okay, so we're now down to acidic salts. It's the last one. Hopefully you've realized exactly what acidic salts are. The cation is from a weak base, and the anion is from a strong acid. Okay, hopefully that wasn't too much of a shocker for you. We're kind of getting there. So let's use NH4Cl as our example. So our example is NH4Cl. So Cl is from hydrochloric acid, NH4 is from NH3 ammonium. Okay, so the cation, is a conjugate acid. Oh boy, I put the G in the wrong. Conju. Oh, no, I cannot imagine. There we go. Get acid. Boy, once you mess up in the middle of that word, it is impossible to get your bearings. Okay, so the cation is a conjugate acid. So what that's going to look like, I have NH4Cl. That's going to dissociate in water to form NH4 plus and Cl minus. Okay, and then the Cl is just going to float off. It's a spectator ion, doesn't really do anything. But the NH4 is a conjugate acid, so that's going to form an equilibrium with water. All right, that's going to form an equilibrium. Forgot my water. That's going to form an equilibrium with my water to give me a hydronium and an NH3. Right there, that's an acid. So cations from a weak base are conjugate acids, and that conjugate acid is a proton donor. It donates the proton to the water. Okay, so that's why that's why acidic salts come from weak bases. It isn't as if the strong acid anion somehow wrestles and forms, makes it acidic or anything. It's actually because of the base has a conjugate acid. Now, that's not true for strong ones, because strong acids and bases don't form conjugate acids. They just form spectator ions. Boy, wow, that's amazing. I should write in green never again. Okay, wow. Okay, well, I guess just green. That's awesome. Okay. So, now you might be going, well, Mr. Wood, that's great. So I have a strong is neutral. A strong base and a weak acid is basic. A strong acid and a weak base is, I forgot what I said, a strong acid and a weak base is acidic. All right? But what if they're both weak? What if they're both weak? What about a weak acid and a weak base? Why I decided to write that above the little green writing that hasn't erased, I don't know, because I'm going to have to continue this down here. Okay, so if I have a weak and a weak, it depends. It depends. Now we have to look at Kas and Kbs. If the Ka is greater than the Kb, the salt's going to be acidic. And that's because if the Ka is greater, I'm going to have more of the acid dissociating, because Ka is the amount that dissociates. So if I have more acid dissociate, I'll have more just the conjugate base. All right? That doesn't make any sense, but that's what it is. Don't listen to my reasoning ever. That's just a horrible idea. All right? If the Ka is weaker than the Kb, if the Ka is weaker than the Kb, then my salt is basic. Okay, so if it's weaker, or if it's less, I should say, not weaker, less. So if my Ka is greater, it's acidic. If my Kb is greater, it's basic. And then if they're the same, if my Ka equals my Kb, you can probably guess what this is. My salt is neutral. Okay, my salt is neutral. Okay, so that is the pH of salts. I hope you enjoyed yourselves, and I hope you have a little bit more appreciation of the stuff that you put on your food. All right, thank you. Have a great day.